Hi there! We will conduct an experiment to know what will be the outcomes of the salt if we put in a glass of water.
I am supposed to add 2 tablespoons of salt in my own glass of water.
And I'm doing the same as Kurt. Whoa! This glass of water becomes so cold.
Wow, my glass of water became hot.
Huh? Why did it have different outcomes? We both use a salt. Why is it my glass of water turns cold after adding the salt to water, while Kurt turns hot?
Kurt and Jurek have a different outcomes when they add salt to their glass of water. It is because they use different salts. The salt that Derek used is ammonium nitrate, which causes an endothermic reaction in the glass of water, while Kurt's salt is calcium chloride, which causes an exothermic reaction in the glass of water. But the question is, what is an endothermic and exothermic reaction or processes? What is their difference? Endothermic processes requires an input of energy to proceed and are signified by a positive change in enthalpy. Considering the reaction mixture, which is the salt and water that Derek and Kurt experimented as the system, and the glass of water as the surrounding. Endothermic reaction usually feels cold because it is taking heat away from you. In Derek's experimentation, when he put the ammonium nitrate on the glass of water, it was dissolved. The system, which is the mixture, absorbed heat from the surroundings, which is the glass of water, and therefore the glass of water became cold. The reaction in Derek's glass of salt can be represented as this. As you can see, heat is absorbed during this reaction, decreasing the temperature of the reaction mixture. Exothermic is the processes in which it releases energy upon combustion and are signified by a negative change in enthalpy. Exothermic reaction usually feel hot because it is giving heat to you. Example in Kurt's experimentation, when he put the calcium chloride on the glass of water, it was dissolved. The system, which is the mixture, releases heat into the surroundings, which is the glass of water, and therefore the glass of water felt hot. The reaction in Kurt's glass of water can be represented as this. Heat is released during the reaction, increasing the temperature of the reaction mixture. An easy way to remember the differences between these two reaction types is by their prefixes. Endo means to draw in, and exo means to give off.
Let's apply Ina's experimentation in real life. Sprain your ankle, you probably reach for an instant cold packs, right? In the bag, there are 2 components that we have, the water and ammonium nitrate. When the bag is broken up, the water and ammonium nitrate mix. The endothermic reaction that makes water colder and the bag makes feel frosty and good for your swollen ankle. Add a small amount of detergent and add water. You will feel heat. Just because of sodium carbonate are rearranged in water, realizing energy is heat. But be sure to wash your hands thoroughly with water, since detergent dries out skin.
An enthalpy is considered to be the sum of the internal energy system and the pressure and volumes product. You can distinguish enthalpy as H. And there are common units for you to use to express enthalpy, and these are joules, calorie, and BTU, or also known as British Thermal Unit. Since total enthalpy is not measurable because 0 point is impossible to identify, change in enthalpy can be calculated instead. Nevertheless, between one state and another, measuring the difference in enthalpy is possible. Enthalpy change can be calculated under the conditions of constant pressure.
Change in enthalpy can apply to refrigerators and hand warmers. Refrigerants such as freon are evaporated. The enthalpy of evaporation, liquid to gas energy change, is equivalent to the coldness of your food. Some people use chemical heat packs like hand warmers outside.